In this video, we are going to look at the Lewis structures of covalent compounds. If you recall, covalent compounds share electrons. So when we're drawing the Lewis structure of covalent compounds, we need to show how the electrons are shared between two atoms. And this is how the atoms achieve the octet rule. So in a covalent compound, we have two or more nonmetals that are bonded together by sharing electrons. So a shared pair of electrons is indicative of a bond, and in a Lewis structure, it is shown by drawing a line. So if we look at the example of H2, I can look at my two Lewis symbols, and in order to achieve the octet, these two electrons are just going to be shared between those hydrogens. Now remember, with hydrogen, it's only can have two electrons around it. So here the duet rule is fulfilled. I have two electrons around my first hydrogen because these two electrons are being shared in the bond. And then I have two electrons that are being shared to the other hydrogen because we have this constant back and forth. If we look at another example for something like oxygen, oxygen is in group 6, so I'm going to have a total of 6 electrons around it. And we are going to have to share some of these electrons in order to achieve our octet rule. So I can share these two electrons, and when I do that, I have created a bond between the two oxygens. And this is what I will be left with. When I count how many electrons are around each oxygen, I have two here, and two in my bond. So there's going to be 2, 4, 6, but I only have one right here for a total of 7. So is my octet rule fulfilled? No, it's not. So I'm going to have to do some more sharing. And I can take my other lone electron and put it into another bond and form what is called a double bond for my oxygen. So now I'll draw two lines between my oxygens. Remember, each line is two electrons. So when I check my octet rule, I have, whoa, I don't want that. There we go. I have two electrons here, two electrons here. But now since I have two bonds drawn, I have a total of 4. So 2 electrons here, 2 electrons here, but 4 here for a total of 8. There are different types of electrons within this Lewis structure. I have what are called lone pair electrons. And lone pair electrons do not participate in bonding. But it's very important to realize that they still exist in that area. They still are part of the molecule. They just don't participate in the bonding. The other type of electrons we have are the bonding electrons. And you got it. The bonding electrons participate in bonding. So when we draw out our oxygen, These electrons here are my bonding electrons. And all of the two electrons, all of the dots, these are all my lone pair electrons. And this is where I see some confusion. There are four lone pairs, but a total of eight lone pair electrons. So make sure you get that distinction correct in your brain. Now, these Lewis structures were pretty simple to put together. They just looked like puzzles, and we pieced our puzzle together and got the Lewis structure. You're not always going to have that ability, and our Lewis structures can get a lot more complicated. So here are the steps for drawing a Lewis structure. And I promise you, if you follow these steps in this order, then you will come up with the correct Lewis structure almost every single time. If you don't, and you just kind of start drawing stuff, that's where I see a lot of mistakes. So the first thing you want to do is determine the total number of valence electrons in the compound. And I would say about 93% of the issues I see with Lewis structures come from the fact that people don't do this first step. So the number of valence electrons must equal the number of electrons in the Lewis structure. Whoa, that was a little bizarre. So the number of valence electrons need to equal the number of electrons in the Lewis structure. I'm telling you, people skip this step all the time, especially as you get more comfortable with drawing out Lewis structures. But this is, if you just double check that the number of valence electrons is equal to the number of electrons in your Lewis structure, you will get rid of a lot of mistakes. The next thing you want to do is draw the skeletal structure. For this class, we will have one central atom only. So you're going to identify the central atom. It's either going to be the first atom drawn in the chemical formula if there's only two types of atom, or it'll be the central atom if there is more than two types of atom. There is one big exception. Hydrogen can never be the central atom. And that's because it's just not big enough. It can only ever hold one electron. So or sorry, it can only hold one bond. It can have a total of two electrons around it, so it can't ever be the central atom. From there, you want to draw a line from the central atom to each outer atom. This is important in this class. You're never going to draw a line between the outer atoms. When you draw that line, remember each line represents two bonding electrons. So however many lines you draw, you need to multiply it by 2 to see how many bonding electrons you have. Once you have that number, you're going to subtract that from the valence electrons. And these are your leftover electrons. You're going to distribute them around the outer atom first. And then if you run out of room, you'll go to the central atom. At this point, you're just going to check your octet rules. Make sure every atom has 8 electrons around it, with the exception of hydrogen. It only likes 2. And then if they don't, you can start adding double and triple bonds if necessarily, similar to what we did with oxygen. Oof. Now that is a lot of steps. Let's go through an example and see how we use these steps. So the first example we're going to do is methane, CH4. In this example, I only have two different types of atoms. I have carbon and I have hydrogen. So remember, if you have two types of atom, your central atom will always be the first atom drawn, with the exception of what? You got it, with the exception of hydrogen because hydrogen can only ever have 2 electrons around it. So I'm going to draw my central atom, methane, and then I'm going to draw my 4 hydrogens around my central atom. It doesn't really matter where they go, but just keep in mind that molecules like to be symmetrical. So if you have the ability to have symmetry, go ahead and do that. So now I am going to count the number of valence electrons I have. Carbon has 4 valence electrons, and I only have 1 carbon atom, so that's going to be a total of 4 valence electrons for carbon. Man, my pen is not super happy today. I don't want to add any pages. Go away. There we go. So there's going to be a total of 4 valence electrons from carbon. Hydrogen has 1 valence electron. But now I have 4 hydrogen atoms, so I'll get a total of 4 valence electrons from my hydrogen as well. And that will give me a total of 8 valence electrons. So when I draw my Lewis structure, I should have a total of 8 electrons. The next step is to draw a line between your central atom and your outer atoms. So I'm just going to draw a line from carbon to hydrogen all the way around. This is what I was talking about earlier. You're never going to see this situation here where you draw a line between the 2 outer atoms. You just won't. Does it exist? Absolutely. But we're just not going to cover it in this class. So I drew a total of 4 lines, which means I have dealt with 8 electrons because remember, there are 2 electrons in each bond. So I'm going to subtract 8 bonding electrons. Notice I've used all my electrons. So my final step is going to be checking to see if my octet rules are fulfilled. 2 electrons around hydrogen, 2 electrons around hydrogen. All of my hydrogens have 2 electrons around it. When I look at my carbon, I have 1, 2, 3, 4 bonds around it. Each bond is 2 electrons, so I have a total of 8 electrons. 2, 4, 6, 8. I have a total of 8 electrons, which matches the number of valence electrons. So this is the Lewis structure for methane, CH4. Let's look at water, H2O. Hydrogen has 1 valence electron, and I have 2 atoms, which will give me a total of 2 valence electrons from my hydrogen. Oxygen has 6 valence electrons, and I have 1 of them. So I have a total of 6 valence electrons from oxygen, which gives me a total of 8 valence electrons for my molecule. Now we said that the first atom is going to be your central atom. But look at what our first atom is. It's hydrogen. Can we ever have hydrogen be our central atom? No, it's not big enough. I can't have, don't write this down, hydrogen bonded to an oxygen and a hydrogen because now I have 4 electrons around hydrogen. Hydrogen is too small. It doesn't have any other orbitals to make that happen. It only has access to one s orbital. So it can only fit 2 electrons around it. So, since the only other atom I have is oxygen, that is going to be my central atom. We will put oxygen in the middle, and then I'm going to put hydrogen on each side. So I have my skeleton structure, and I'm going to draw a line between my central atom to my outer atoms. Since I drew 2 lines, I am going to subtract 4 bonding electrons. Look at this. Now I have some leftover electrons. I need to distribute those electrons within my Lewis structure. So the rule is I'm going to look at my outer atoms first. Both of my outer atoms are hydrogen, and there is no room for any lone pairs on this. So I'm going to take those electrons and put them around my central atom, which is oxygen. I drew 4 lone pair electrons, so I've used all of my valence electrons. Now I need to check my octet. Both of my oxygens have one bond, so they have a total of 2 electrons each. The duet is fulfilled. Now my oxygen, I have 2 lone pairs and I have 2 bonds. That gives me a total of 8 electrons, and my octet is fulfilled. Something I want you to be aware of is that in this molecule, there are 4 electron areas around oxygen. Lone pairs count too. They take up space. A lot of times when people look at this molecule, they think there's only 2 things around the oxygen because they only want to count the bonding electrons. But the lone pair electrons take up space as well. All right, let's look at 2 more examples. We have carbon dioxide, CO2, and NH3, ammonia. What I would really like you to do is pause this video, go through your steps, see if you can come up with the Lewis structures of these compounds, and then come back and we can do them together. All right, hopefully you have your Lewis structures. Let's look at this together. For this one, I'm just going to get the total valence electrons. I'm not going to show again how I got them. So carbon has a total of 4. And oxygen has 6 valence electrons, but I have 2 of them for a total of 12. So there's going to be 16 valence electrons. Carbon is written first, so it is going to be my central atom. And then I'm going to draw my 2 oxygens on each side. Now I'm going to connect the carbon and the oxygen by drawing a line from my carbon to my oxygens. I drew 2 lines, so that gives me a total of 4 bonding electrons. When I subtract my bonding electrons from my valence electrons, I have 12 electrons left. Yeah, I don't know what's going on. So we have 12 valence electrons left. I'm going to distribute those 12 electrons around my outer atoms first, and then if I have more left over, I'm going to go around my central atom. So I put 6 on my first oxygen. I can't, there's no room for any more of them because I can only have a total of 8 things around it. So now I'm going to go and distribute the rest of them on my other oxygen. And I have used up all of my electrons because I have 12 lone pair electrons. Now I need to check my octets. I notice with my oxygens, I have a total of 8 electrons around each of my oxygen. Now, if we look at our carbon, I only have 4 electrons. So now we have to form our double or triple bonds. Doing that means we're going to take these 2 electrons and put them into a bond. So we can form a double bond between oxygen and carbon. So I can move those electrons and put them into a bond. So we form the double bond. Notice that when we did that, I have 4 lone pair electrons and 4 bonding electrons. So around oxygen, I still have 8 electrons. The octet rule is still fulfilled, but I've added electrons around my carbon. Now, to achieve the octet for carbon, I can just take another of my lone pair electrons, and I can put them into a bond here. Again, when I do that, I still have 8 electrons around my oxygen, but now I've fulfilled the octet rule for carbon. A question I get all the time is, does it matter how you draw your lone pairs? No, it doesn't. Notice drawing them like this is still the same answer. But what I want you to remember is these are lone pair electrons, which means you can't draw them like this because now I've split up that pair. So we still want to make sure we have our lone pair electrons in pairs. But either of these structures for carbon dioxide are totally appropriate. All right, let's look at ammonia, NH3. I'm going to have a total of 8 valence electrons. Nitrogen is written first, so that is going to be my central atom. And I'm going to draw 3 hydrogens around my nitrogen. Then I'm going to draw a line between my nitrogen and each one of my hydrogens. Since I drew 3 lines, that is going to represent 6 bonding electrons, which means I'm going to have 2 valence electrons left over. The rule is I need to distribute it around my outer atoms first, and then I can put it on my central atom. Is that possible? Absolutely not. We cannot put more electrons around the hydrogen because hydrogen can only have 2 electrons around it, which means I need to distribute my lone pair on my central. And in doing so, I've used up all of my electrons. So I don't have any leftover electrons to deal with. Each one of my hydrogens fulfill their duets, and nitrogen has 6 electrons from bonds, 2 from lone pairs for a total of 8 electrons. This is also something I get asked a lot. These 2 Lewis structures are the same. It really doesn't matter which way you want to draw them.